COBOL is a compiled English-like computer programming language designed for business use. It is imperative, procedural and, since 2002, object-oriented. COBOL is primarily used in business, finance, and administrative systems for companies and governments. COBOL is still widely used in legacy applications deployed on mainframe computers, such as large-scale batch and transaction processing jobs, but due to its declining popularity and the retirement of experienced COBOL programmers, programs are being migrated to new platforms, rewritten in modern languages or replaced with software packages. Most programming in COBOL is now purely to maintain existing applications. COBOL was designed in 1959 by CODESYL and was partly based on previous programming language design work by Grace Hopper, commonly referred to as the mother of COBOL. It was created as part of a U.S. Department of Defense effort to create a portable programming language for data processing. Intended as a stopgap, the Department of Defense promptly forced computer manufacturers to provide it, resulting in its widespread adoption. It was standardized in 1968 and has since been revised 4 times. Expansions include support for structured and object-oriented programming. The current standard is ISO IEC 1989-2014. COBOL has an English-like syntax, which was designed to be self-documenting and highly readable. However, it is verbose and uses over 300 reserved words. In contrast with modern, succinct syntax like y equals x, COBOL has a more English-like syntax. COBOL code is split into 4 divisions containing a rigid hierarchy of sections, paragraphs and sentences. Lacking a large standard library, the standard specifies 43 statements, 87 functions and just 1 class. Academic computer scientists were generally uninterested in business applications when COBOL was created and were not involved in its design. It was designed from the ground up as a computer language for businessmen, with an emphasis on inputs and outputs, whose only data types were numbers and strings of text. COBOL has been criticized throughout its life, however, for its verbosity, design process and poor support for structured programming, which resulted in monolithic and incomprehensible programs. History and specification. Background. In the late 1950s, computer users and manufacturers were becoming concerned about the rising cost of programming. A 1959 survey had found that in any data processing installation, the programming cost $800,000 on average, and that translating programs to run on new hardware would cost $600,000. At a time when new programming languages were proliferating at an ever-increasing rate, the same survey suggested that if a common business-oriented language were used, conversion would be far cheaper and faster. In April 1959, representatives from academia, computer users and manufacturers met at the University of Pennsylvania to organize a formal meeting on common business languages. Representatives included Grace Hopper, inventor of the English-like data processing language Flowmatic, Gene Sabat and Saul Gorn. The group asked the Department of Defense to sponsor an effort to create a common business language. The delegation impressed Charles A. Phillips, director of the Data System Research staff at the DoD, who thought that they thoroughly understood the DoD's problems. The DoD operated 225 computers, had a further 175 on order, and had spent over $200 million on implementing programs to run on them. Portable programs would save time, reduce costs and ease modernization. Phillips agreed agreed to sponsor the meeting and tasked the delegation with drafting the agenda. On May 28 and 29 of 1959, a meeting was held at the Pentagon to discuss the creation of a common programming language for business. It was attended by 41 people and was chaired by Phillips. The Department of Defense was concerned about whether it could run the same data processing programs on different computers. Fortran, the only mainstream language at the time, lacked the features needed to write such programs. Representatives enthusiastically described a language that could work in a wide variety of environments, from banking and insurance to utilities and inventory control. They agreed unanimously that more people should be able to program and that the new language should not be restricted by the limitations of contemporary technology. A majority agreed that the language should make maximal use of English, be capable of change, be machine independent, and be easy to use, even at the expense of power. The meeting resulted in the creation of a steering committee and short, intermediate and long-range committees. The short-range committee was given to September to produce specifications for an interim language, which would then be improved upon by the other committees. Their official mission, however, was to identify the strengths and weaknesses of existing programming languages and did not explicitly direct them to create a new language. The deadline was met with disbelief by the short-range committee. One member, Betty Holberton, described the 3-month deadline as gross optimism and doubted that the language really would be a stopgap. The steering committee met on June 4 and agreed to name the entire activity as the Committee on Data Systems Languages, or CODSYL, and to form an executive committee. The short-range committee was made up of members representing 6 computer manufacturers and 3 government agencies. The 6 computer manufacturers were Burroughs Corporation, IBM, Minneapolis Honeywell, RCA, Sperry Rand, and Sylvania Electric Products. The 3 government agencies were the U.S. Air Force, the Navy's David Teller Model Basin, and the National Bureau of Standards. The committee was chaired by Joseph Wegstein of the U.S. National Bureau of Standards. Work began by investigating data description statements, existing applications and user experiences. The committee mainly examined the Flowmatic, AIMACO and COMTRAN programming languages. The Flowmatic language was particularly influential because it had been implemented and because AIMACO was a derivative of it with only minor changes. Flowmatic's inventor, Grace Hopper, also served as a technical advisor to the committee. Flowmatic's major contributions to COBOL were long variable names, English words for commands, and the separation of data descriptions and instructions. IBM's COMTRAN language, invented by Bo Beamer, was regarded as a competitor to Flowmatic by a short-range committee made up of colleagues of Grace Hopper. Some of its features were not incorporated into COBOL so that it would not look like IBM had dominated the design process, and Gene Summit said in 1981 that there had been a strong anti-IBM bias from some committee members. In one case, after Roy Goldfinger, author of the COMTRAN manual, an intermediate-range committee member, attended a subcommittee meeting to support his language and encourage the use of algebraic expressions. Grace Hopper sent a memo to the short-range committee reiterating Sperry Rand's efforts to create a language based on English. In 1980, Grace Hopper commented that COBOL 60 is 95% Flowmatic and that COMTRAN had an extremely small influence. Furthermore, she said that she would claim that work work was influenced by both Flowmatic and COMTRAN. Only to keep other people happy wouldn't try to knock us out. Features from COMTRAN incorporated into COBOL included formulas, the picture clause, an improved if statement, which obviated the need for GOTOs, and a more robust file management system. The usefulness of the committee's work was subject of great debate. While some members thought the language had too many compromises and was the result of design by committee, others felt it was better than the 3 languages examined. Some felt the language was too complex, others, too simple. Controversial features included those some considered useless or too advanced for data processing users. Such features included Boolean expressions, formulas and table subscripts. Another point of controversy was whether to make keywords context-sensitive and the effect that would have on readability. Although context-sensitive keywords were rejected, the approach was later used in place and partially in COBOL from 2002. Little consideration was given to interactivity, interaction with operating systems and functions. The specifications were presented to the Executive Committee on September 4. They fell short of expectations. Joseph Wegstein noted that it contains rough spots and requires some additions, and Bob Beamer later described them as a hodgepodge. The subcommittee was given until December to improve it. At a mid-September meeting, the committee discussed the new language's name. Suggestions included Busy, INFOSYL, and COCOSYL. The name COBOL was suggested by Bob Beamer. In October, the Intermediate Range Committee received copies of the fact language specification created by Roy Nutt. Its features impressed the committee so much that they passed a resolution to base COBOL on it. This was a blow to the Short Range Committee, who had made good progress on the specification. Despite being technically superior, FACT had not been created with portability in mind through manufacturer and user consensus. It also lacked a demonstrable implementation, allowing supporters of a Flowmatic-based COBOL to overturn the resolution. RCA Representative Howard Bromberg also blocked FACT, so that RCA's work on a COBOL implementation would not go to waste. It soon became apparent that the committee was too large for any further progress to be made quickly. A frustrated Howard Bromberg bought a $15 tombstone with COBOL engraved on it and sent it to Charles Phillips to demonstrate his displeasure. A subcommittee was formed to analyze existing languages and was made up of 6 individuals: William Selden and Gertrude Tierney of IBM, Howard Bromberg and Howard Discount of RCA, Vernon Reeves and Jean E. Sammet of Sylvania Electric Products. The subcommittee did most of the work creating the specification, leaving the Short Range Committee to review and modify the work before producing the finished specification. The specifications were approved by the Executive Committee on January 3, 1960, and sent to the Government Printing Office, which printed these as COBOL 60. The language's stated objectives were to allow efficient portable programs to be easily written, to allow users to move to new systems with minimal effort and cost, and to be suitable for inexperienced programmers. The CODASYL Executive Committee later created the COBOL Maintenance Committee to answer questions from users and vendors and to improve and expand the specifications. During 1960, the list of manufacturers planning to build COBOL compilers grew. By September, 5 more manufacturers had joined CODASYL, National Cash Register and Philco. and all represented manufacturers had announced COBOL compilers. GE and IBM planned to integrate COBOL into their own languages, GECOM and COMTRAN, respectively. In contrast, International Computers and Tabulators planned to replace the language CODEL with COBOL. Meanwhile, RCA and Sperry Rand worked on creating COBOL compilers. The first COBOL program ran on the 17th of August on an RCA 501. On December 6 and 7, the same COBOL program ran on an RCA computer and a Remington Rand UNIVAC computer, demonstrating that compatibility could be achieved. The relative influences of which languages were used continues to this day in the recommended advisory printed in all COBOL reference manuals. COBOL is an industry language and is not the property of any company, a group of companies, or of any organization, a group of organizations. No warranty, expressed or implied, is made by any contributor or by the CODESYL COBOL Committee as to the accuracy and functioning of the programming system and language. Moreover, no responsibility is assumed by any contributor or by the committee in connection therewith. The authors and copyright holders of the copyrighted material used herein are as follows: Flowmatic Programming for the UNIVACI and 2. Data Automation Systems, copyrighted 1958-1959, by Unisys Corporation, IBM Commercial Translator Form No. F28-8013, copyrighted 1959 by IBM, Fact, DSI 27A52602760, copyrighted 1960 by Minneapolis Honeywell. They have specifically authorized the use of this material, in whole or in part, in the COBOL specifications. Such authorization extends to the reproduction and use of COBOL specifications in programming manuals or similar publications. COBOL 61 to COBOL 65. Many logical flaws were found in COBOL 60, leading GE's Charles Katz to warn that it could not be interpreted unambiguously. A reluctant short-term committee enacted a total clean-up, and by March 1963, it was reported that COBOL's syntax was as definable as ALGOL's, although semantic ambiguities remained. Early COBOL compilers were primitive and slow. A 1962 U.S. Navy evaluation found compilation speeds of 3 to 11 statements per minute. By mid-1964, they had increased to 11-1000 statements per minute. It was observed that increasing memory would drastically increase speed and that compilation costs varied wildly. Costs per statement were between 23 cents and $18.91. In late 1962, IBM announced that COBOL would be the primary development language and that development of COMTRAN would cease. The COBOL specification was revised 3 times in the 5 years after its publication. COBOL 60 was replaced in 1961 by COBOL 61. This was then replaced by the COBOL 61 extended specifications in 1963, which introduced the sort and report writer facilities. The added facilities corrected flaws identified by Honeywell in late 1959 in a letter to the Short Range Committee. COBOL Edition 1965 brought further clarifications to the specifications and introduced facilities for handling mass storage files and tables. Efforts began to standardize COBOL to overcome incompatibilities between versions. In late 1962, both ISO and the United States of America Standards Institute formed groups to create standards. ANSI produced USA Standard COBOL X 3.23 in August 1968, which became the cornerstone for later versions. This version was known as American National Standard COBOL and was adopted by ISO in 1972. By 1970, COBOL had become the most widely used programming language in the world. Independently of the ANSI Committee, the CODESYL Programming Language Committee was working on improving the language. They described new versions in 1968, 1969, 1970 and 1973, including changes such as new inter-program communication, debugging and file merging facilities, as well as improved string handling and library inclusion features. Although CODESYL was independent of the ANSI Committee, the CODESYL Journal of Development was used by ANSI to identify features that were popular enough to warrant implementing. The Programming Language Committee also liaised with the ECMA and the Japanese COBOL Standard Committee. The Programming Language Committee was not well known, however. The Vice President, William Reinholz, complained that two-thirds of the COBOL community did not know of the committee's existence. It was also poor, lacking the funds to make public documents, such as minutes of meetings and change proposals, freely available. In 1974, ANSI published a revised version of COBOL, containing new features such as file organizations, the delete statement and the segmentation module. Deleted features included the note statement, the examine statement and the implementer-defined random access module. These made up 44 changes, which rendered existing statements incompatible with the new standard. The report writer was slated to be removed from COBOL, but was reinstated before the standard was published. ISO later adopted the updated standard in 1978. In June 1978, work began on revising COBOL 74. The proposed standard differed significantly from the previous one, causing concerns about incompatibility and conversion costs. In January 1981, Joseph D. Brophy, Senior Vice President of Travelers Insurance, threatened to sue the Standard Committee because it was not upwards compatible with COBOL 74. Mr. Brophy described previous conversions of the 40 million line code base as non-productive and a complete waste of our programmer resources. Later that year, the Data Processing Management Association said it was strongly opposed to the new standard, citing prohibitive conversion costs and enhancements that were forced on the user. During the first public review period, the committee received 2,200 responses, of which 1,700 were negative formed letters. Other responses were detailed analyses of the effect COBOL 80 would have on the systems. Conversion costs were predicted to be at least 50 cents per line of code. Fewer than a dozen of the responses were in favor of the proposed standard. In 1983, the DPMA withdrew its opposition to the standard, citing the responsiveness of the committee to public concerns. In the same year, a National Bureau of Standards study concluded that the proposed standard would present few problems. A year later, a COBOL 80 compiler was released to DECVAX users, who noted that conversion of COBOL 74 programs posed few problems. The new evaluate statement and inline perform were particularly well received and improved productivity, thanks to simplified control flow and debugging. The second public review drew another 1,000 responses, while the last drew just 25, by which time many concerns had been addressed. In late 1985, ANSI published the revised standard. 60 features were changed or deprecated and many were added, such as scope terminators, nested subprograms, continue, and no operation statement. Evaluate a switch statement. Initialize a statement that can set groups of data to their default values. Inline perform loop bodies. Previously, loop bodies had to be specified in a separate procedure. Reference modification, which allows access to substrings. I/O status codes. The standard was adopted by ISO the same year. Two amendments followed in 1989 and 1993, the first introducing intrinsic functions and the other providing corrections. ISO adopted the amendments in 1991 and 1994 respectively, before subsequently taking primary ownership and development of the standard. COBOL 2002 and object-oriented COBOL. In 1997, Gartner Group estimated that there were a total of 200 billion lines of COBOL in existence, which ran 80% of all business programs. In the early 1990s, work began on adding object orientation in the next full revision of COBOL. Object-oriented features were taken from C++ and Smalltalk. The initial estimate was to have this revision completed by 1997, and an ISO committee draft was available by 1997. Some vendors introduced object-oriented syntax based on drafts of the full revision. The final approved ISO standard was approved and published in late 2002. Fujitsu, GT Software, Micro Focus and Rain Code introduced object-oriented COBOL compilers targeting the .NET framework. There were many other new features, many of which had been in the CODESYL COBOL Journal of Development since 1978 and had missed the opportunity to be included in COBOL 85. These other features included free-form code, user-defined functions, recursion, locale-based processing, support for extended character sets such as Unicode, floating point and binary data types, portable arithmetic results, bit and Boolean data types, pointers and syntax for getting and freeing storage, the screen section for text-based user interfaces, the validate facility, improved interoperability with other programming languages and framework environments such as .NET and Java. 3 core agenda were published from the standard, 2 in 2006 and 1 in 2009. Between 2003 and 2009, 3 technical reports were produced describing object finalization, XML processing and collection classes for COBOL. COBOL 2002 suffered from poor support. No compilers completely supported the standard. Micro Focus found that it was due to a lack of user demand for the new features and due to the abolition of the NIST test suite, which had been used to test compiler conformance. The standardization process was also found to be slow and under-resourced. COBOL 2014 includes the following changes. Portable arithmetic results have been replaced by IEEE 754 data types. Major features have been made optional, such as the validate facility, the report writer and the screen handling facility. Method overloading, dynamic capacity tables. Legacy COBOL programs are used globally in governments and businesses and are running on diverse operating systems such as z/OS, VM, Unix, OpenEVMs and Windows. In 1997, the Gartner Group reported that 80% of the world's business ran on COBOL, with over 200 billion lines of code and 5 billion lines more being written annually. Near the end of the 20th century, the year 2000 problem was the focus of significant COBOL programming effort, sometimes by the same programmers who had designed the systems decades before. The particular level of effort required to correct COBOL code has been attributed to the large amount of business-oriented COBOL, as business applications use dates heavily and to fixed-length data fields. After the clean-up effort put into these programs for Y2K. A 2003 survey found that many remained in use. The author said that the survey data suggest a gradual decline in the importance of COBOL in application development over the 10 years unless integration with other languages and technologies can be adopted. In 2006 and 2012, Computerworld surveys found that over 60% of organizations used COBOL and that for half of those, COBOL was used for the majority of their internal software. 36% of managers said they planned to migrate from COBOL, and 25% said they would like to if it was cheaper. Instead, some businesses have migrated their systems from expensive mainframes to cheaper, more modern systems, while maintaining the COBOL programs.